Hi team, Mr. Rator here, Bridging Course Section 7, looking at basic indices. So you'll start with some really basic and then move on to some tougher ones, what you see in at GCSE level. Let's go at this one first. So a cubed times a squared, when you multiply, we simply just add the powers there, 3 plus 2, which will equal a to the power 5. Okay, when we divide in and the base is the same, we subtract the powers, so it would be 14, subtract 5, which will give me a to the power 9. Okay, very simple so far. Now, we got to something like this, we're multiplying, so this is, first of all, 4 times 5 is 20. And just be careful, this is a multiplication sign, so these x's are the ones that are, the base are the same, so you got x 2, we times them, we add the powers, 2 plus 4. Okay, so remember 4 times 5 is 20, then the x squared times x to the power 4 is 2 plus 4, so that will give me 20 x to the power 6. Okay, let's draw that. Now, just be careful here, so we've got, first of all, let's do the multiplication, so keep that base the same, 7 plus 3 is 10, divided by a to the power 5. Now we do the subtraction, subtract the powers, so it's going to be 10 minus 5, as the base is the same, so that's going to give me a to the power 5. Okay, let's do the same thing here. First of all, let's just do the numerator, so we got 10 times 2 is 20, and y to the power 2 times y to the power 4, so that's going to be y to the power 6 over 4, y to the power 3. Now, first of all, let's do the division. 20 shared by 4 is 5. And then we're going to subtract the powers. The base is the same, so 6 subtract 3 is 3. Okay. Very standard, straightforward at the moment. And just be careful here. Times in, we mean add the powers, so we're going to get 3, add minus 3. Now, plus and minus makes a minus, so it's going to be 3 minus 3, so you end up with b to the power 0. As you know, that anything to the power 0 is 1. Okay. Shared by itself is 1. I find this will be a good way to demonstrate this actually, because times in this is the same as b to the 3 times, now when it's a negative, it's 1 over b to the 3. So times in those, that is the same as b to the 3 over b to the 3. So anything divided by itself is 1, as we just said there. It's a nice way to show that. Okay, question 7. Let's just have a quick look at this. First of all, let's do the numbers always first. 2 times 3 is 6. Then x and x to the x's, we're going to add the power, so that's going to give me x2 plus 3 when we times it, and y is going to be, now if there's no power there, you got 1 there. Okay, it's always to the power 1 if there's nothing else there. That's going to be 1 plus 2. And that's going to end up as 6 x to the power 5 y to the power 3. Okay, let's do question 8. Again, 8 times 4, 8, 16, 24, 32. Then you got the y's. Y is going to be, you got 2 there and a 7 there, so it's 2 plus the 7. And you got the z, which is 5. This is to the power 5, and this is power 3 because we're all multiplying. That's going to be 32 y to the power 9 and z to the power 8. Okay. Now, question 9. Sorry, I'm going through this pretty fast, but you should be able to do this pretty straightforward so far. There's not too much complicated stuff going on. And just be careful here. This is 24 times c to the power 0. Now anything to the power 0 is 1, so that's just going to be 24 times 1, which is just 24. Okay, let's just have a look at this. We'll do this in steps so that what's going on. Let's just first of all, how many 4 is going to 20 is 5, so 20 shared by 4 is 5, and 4 divided by 4 is 1. Okay, so you'll end up with just at the moment we've got j squared. So what I'm going to do is you got j squared at the top, that's the same as j times j. So what I'm going to do, actually let's just do this a simpler way. So let's just write this out all longhand the way I do it at GCSE level, so we can see what exactly is going on here. Yeah, let's just start all this again. Let's try this way. So that's going to be 4 times j squared is j times j, k to the power 4, so we got 1, 2, 3, 4 times l to the power 6, we got 1, 2, 3, 4, 5, 6 of those. All over. Now 20 can be written as 4 times 5. We've got 5 j's times 1, 2, 3, 4, 5 times k to k squared times 1, 2, 3, 4, 5. Okay, so let's just use a different color there so we can see the cancel. So the 4's will cancel. So 4 divided by 4 is just 1. So the j's will cancel, 1 there and another 1 here. The k's will cancel, 1k there, another k there, and the l's going to cancel, 1 from that one, 2, 3, 4, 5 l's cancel. So what you end up at the top, all these, when I cancel them, ends up as 1. So 1 times 1 is just 1. So they're all gone. So I'm going to end up with 2 k's at the top, which is going to be k squared and l, 1l. And what I'm going to end up at the bottom is a 5 and 1, 2, 3, 1, 2, 3 j to the power 3 and nothing else. You could have seen this straight away from here. 4's into 4 is 1, 4's into 20 is 5. Then you got more j's at the bottom. How many more? 3. So that's cubed there. Got more k's at the top. So how many k's? 2's. That's going to be k squared. Got more l's at the top. How many by? 1. So 1 l. Okay. So let's just go on to 11. We'll do the similar thing. So here. Now we could cancel. Cancel the 2's from here and from here, so that ends up being a 5. That ends up being a 2 now, but then there's a 2 here, so that 2 here cancels with that 2, so we only end up with 5 at the top. Okay, so let's just go and collect the x's, then we go and solve the bottom. So we've got x there and x, so that's going to be x squared, so that's x cubed. We've got y squared and y to the power 4, so that's going to end up with y to the power 6, because 4 plus 2 is 6. And z cubed and z squared, so that's going to end up with z to the power 5. And at the bottom we've got x to the power 5, we've got y to the power 4, and we've got z to the power 6. Now, there's no numbers to cancel here, so we just leave 5 on the top. Now, On the bottom, we've got more x's. How many more x's have we got? So if we cancel those 3 out and the 3 from here, we end up with just x on the bottom, but by 2. So 3's have cancelled. Okay, 3 x's have cancelled. How many y's have cancelled? So we've got more y's on top. We've got 4 y's being times by each other here. We've got 6 y times by here. So the 4 y's will cancel at the bottom, and you end up with y squared, 2 y's at the top. So that's going to be y squared at the top. And here, you're going to end up with z at the bottom because you've got 5 and 6 there. There's more here by 1. So z just to the power 1, we just leave it as z, and that's that cancel. Okay, that's it. If you want to write it the longer version here, what we done earlier on in question 10, you can do. But you need to start learning and being careful how to do it in this kind of form, okay, to do it a bit faster. Okay, so when we're getting brackets and we've got the powers, so we just literally times them there. So x is 2 times 3, which gives me x to the power 6. Now the reason why this happens is this is being cubed. Cubed means x squared times x squared times x squared, and then that second rule comes in where if you times in, we add the powers. So 2 plus 2 plus 2 is 6. So you've got to get 3 lots of those 2's. You're better off just times them straight away. Okay, similar to this is being cubed, but don't forget everything's being cubed here. So that's going to be 2 is going to be cubed, and then x squared is going to be cubed, so that's going to be times by 3. So you end up, dot means times in when we get on to more algebra and A-level maths. So the dot, when you see a dot next to each other, it's being multiplying. So that's going to be 8, and that's going to be x to the power 6. Okay. And obviously, if it's dots in numbers, it's decimal point, but just be careful when I put it in algebra. The dot means to multiply. Okay, so let's go on to question 14. We're squaring everything. So 3 is going to be squared. X squared is going to be squared further, so that's going to be times by 2. And y cubed is going to be squared, so that's going to be times by 2. So 3 squared, so everything's going to be squared. So 3 squared is 9. X to the power 4. And y to the power 3 times 2 is 6. Okay, so just going to make sure that is a 3. Let's just quickly make sure we're writing that carefully. Okay, let's move in that. Okay, now no calculators allowed, so again let's have a look at this. Now the base is the same, similar to the thing what we do in algebra. Keep the base the same, 4 plus the 3, and that gives me 2 to the power 7. Now some people have a tendency to times 2 times 2 to give me 4, so don't do that misconception. Keep the base always the same and deal with the powers we add in here. Okay, same thing here. We keep the base the same and just deal with the powers, just as we do in algebra. So that's going to be 12, take away the 8. So that's going to be 2 to the power 4. We can just leave it in surge form, that's fine, unless it says evaluate or give me an answer. Again, keep the base the same. 7 subtract the 4, it's going to give me 3 cubed. Now, question 18, just be careful. When you got 0 there, you got 2, 9 times 0. Anything times 0 is 0, so 2 to the power 0. And any number other than 0 to the power of 0 is going to give me 1. Okay. Now, when we got fractions, also remember that the fraction here means square root. So just make sure that a to the power of a half is equal to a square root. Now I'm using that just as a general term. So this means 81 square root. 81 square root is just 9. Okay, the square root of 81 is 9. Likewise, 169 square root of that is 13. Okay, Now, this is quartic root, or square root, then square root again. So you got 16, the root of 4. So the square root of 16 is 4, square root it again is 2. So just double checking, 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so the quartic root of 16 is 2. Now here, remember, when we're doing this, the way I describe this is you put it in two forms. So if you got a to the 2 over 3, this is the same as cube root, and then the top one is the square. Okay, so this one here is the root. I mean, it's all a power, but this, let's just call that the power. It's all a power, but the bottom, when it's a fraction, the bottom is the root of it, and the top one is the power. We will do as squares. Okay, so just remember that. So if I've got this, I'll do 27, cube root that, and then I square everything. Okay, 2 comes to square. This is the best way to do it. It's always best rooting it then squaring it to avoid massive numbers. So cube root of 27 is 3, and 3 squared is equal to 9. Okay, let's do the same thing here. Now we've got 32. We've got that to the root 5. Then we've got to cube everything after that. So there's the root, and there's the power. Now remember that 2 times 2 times 2 times 2 is 16, and if I times it by 2 again, so 1, 2, that's 4, 8, 16, 32. So the fifth root of that, 1, 2, 3, 4, 5, is 2. So that's going to be 2, and then that's going to be cubed. And we know that 2 cubed, 2 times 2 is 4, times 2 is 8, it's 8. Okay. Here, just be careful. So we're squaring that. So we square each one. So we'll literally write it like 2 over 5 squared is the same as 2 squared over 5 squared. Same as 4 over 25. And the same happens for when we root in something like that. Okay? You should know that from fractions too, that 2 over 5 times 2 over 5 is the same as 2 times 2, 5 times 5, just same as 4 over 25. So when doing this, we've got the same thing. So it's going to be 1 cubed over 3 cubed, which is 1 over 27, for the same reasons. Anything to the power of 0 is just going to give me 1, as we said before. Now negative powers, now just be careful on negative, it means the reciprocal, we'll get rid of the negative, so remember that if I've got a to the minus n, that is the same as 1 over a to the power n. So the negation mark here, the negative 1 means 1 over. Okay, so that will be the same as 1 over 5 to the 1, which is just 1 over 5, just 1/5. And this one will be 1 over 2 to the power of 3. So the 3 has become positive because I put it over 1. So that then becomes 1 over 2 cubed, as we said earlier, was 8, so that's 1/8. Okay, now when we're doing fractions and we've got something like this, and we've got 1/3 to the power minus 2. Now the easiest way to do this is to just turn this fraction upside down. Okay, to get rid of the negative, we turn this upside down. So this becomes 3 over 1. And by doing that, we can change this to a positive. So when it's a negative, when you put 1 over, if you got A over B, okay, and you put that to the minus 1, that is the same as B over A power of minus 1. That's the same as, this is the same as saying it's 1 over A over B, and if I times top and bottom by B to get rid of it, that gives me B over A. That's the thinking behind it. Just be careful when you're doing those. Okay, and so if we finish this off, we'll end up with 3 divided by 1 is just 3, and then 3 squared is just 9. Okay, so let's have a look at this. This one, first of all, I'm going to put 1 over 16 to the quarter, so change that to a positive. And then I know that 1 over, this is the same as 16 to the root of 4. Okay, quartic root, and we worked this out earlier on. 1 over quartic root of 16 is 2. So that's just going to be a half. Same thing here. We can put, first of all, change this to 1 over 1000 to the power 1/3. Now that is the same as cube root, so we get 1000 and we cube root this. Cube root of 1000 is 10, so that's just going to be 1 over 10. That's job done there. Okay, so question 32, let's have a look at this again. Let's just first write this out, 1 over 49 to the power minus a half. And that is the same as, what we just do is turn the fractions upside down, so that will be 49 over 1, and put that to the power positive a half. So 49 divided by 9 is 49, and to the power half is the same as square root. Square root of 49 is 7. And that's your answer. Okay, so that's all of section 7 done, and I look forward to section 8. See you then. Bye.